Good afternoon, everybody. You'll have to forgive me if my voice starts breaking or anything like that. I just came back from a trip where I was doing a lot of talking, a lot of partying. For those who know me, that's really nothing new. So my name's Thomas. I've done a lot of things in my life. I should probably update that line to say almost 30 plus years of experience in InfoSec. I also help run B-Sides London. Brian is in the audience. He's also one of our co-directors. Currently, I actually work for Riot Games, and I run the security operations team for the company. So what I'm going to talk to you about today really doesn't have anything to do with Riot Games. It has something to do with something that's bugged me for a long time in our industry. I've been an incident responder for a number of years. I do a lot of detection engineering and things like that just to try and understand the best way to protect an organization from the threats that could come up, and also to ensure that you're doing things so that you're protected against, for example, the data, so that you have a focus on data protection if you need to do that in your incident response cycles. So why are we here today? Well, I have a fundamental problem. When I look at incident response and when I look at what we're trying to achieve, the threat actors still get in, right? We still get breached. We still have issues where something gets run in our environments and then there's a breach. And then the threat actor is inside. He's starting to act. He's moving laterally. He's getting a footprint, potentially exfiltrating stuff or ransoming your environment. Now, is this a failure of people? I don't know. I'd rather not think it's a failure of people. The reason I don't think it's a failure of people is because I trust the teams I work with. I like to trust the teams I work with. I don't think that anybody that's doing this work is trying to fail. I think they're trying to do the best they can. Is it a failure of procedures? Sometimes it is. I'll be honest with you guys. Sometimes the procedures, the work, your playbooks just don't match what you need to do in your organization to respond. Or is it a failure of technology? And this is where I get stuck, because we spend a massive amount of money on technology, right? We spend literally sometimes millions of dollars a year keeping our technology running, implementing our technology, improving our technology to catch the bad guys. This week, I was at some presentations and this quote came up. I actually kind of like it. Our failures are a consequence of many factors, but possibly one of the most important is the fact that society operates on the theory that specialization is the key to success, and not realizing that specialization precludes comprehensive thinking. This is by Buckminster Fuller. He wrote Spaceship Earth, I think it's called. I can't remember the book exactly, but I have to actually read this because apparently it's pretty good, even though it seems to be far-fetched. But I like the quote because there's a few things that are highlighted, right? The specialization, the comprehensive thinking. But if I replace society by security and I replace specialization by tools, this still works, right? Because some of the security operations that we do, we rely intensely on certain tools. We rely intensely on upgrading our tools or taking new tools into production to help us protect. But we're not actually thinking this through. And one of the reasons is, and I'm sorry if there are any vendors in the audience, but we've got vendor overload. Every few years, a vendor will come up with a new term, and I really like this. This is from Securitiny. Basically, my problem is that vendors are constantly telling us that, we've got this new tool, we've got this new way of doing things, we've got XDR now, we've got all of this stuff, we want to implement zero trust, it'll be better for you. And at the end of the day, vendors are essentially telling us, well, we're the best. We're awesome. We can protect your organization. We can detect everything in the sun. And don't get me wrong. They think they can, but I can test that they probably can't. And the other problem I have too is that, this is a marketing pitch. You evaluate your tools, you do things, but it's kind of pushy. They're kind of constantly telling us that they have the best tools and that they want the best tools. And the problem is they'll usually go pretty high up in the organization to try and sell you on this. So if you have an organization where the CISO, relies on people like Gartner and things like that, tell them what the best tool, what the next best technology is, you start to get kind of peer pressure. You start to get overload from all of these vendors, and you start to feel like you need to adopt these tools, but you don't really know why you're adopting them to a certain extent. And this is something that, I've experienced. You've probably experienced too. I just don't like the idea of us having to buy a tool because it's the new best thing, right? Or because they say they detect everything. And to continue on this kind of rant, and I like to rant, right? Because that's just the way I do things. There's a few people who know me that will tell you that I rant like crazy sometimes. But one of the problems is MITRE ATT&CK. I have mixed feelings about MITRE ATT&CK. If you've seen some of my previous presentations, I will literally cuss this framework. MITRE ATT&CK is really good for defining what threat actors do, the TTPs, to give you an idea of some of the capabilities. It's also a really great framework to explain to people what's going on from a kind of a non-technical, and it's even worse now. It's actually there's a lot more non-technical aspects to it. So that you can actually take a security team, an incident response team, and they can kind of use the MITRE ATT&CK to identify the different steps. They can identify different phases of an attack, but it also helps them communicate better upwards. And I like that. For that, I like MITRE ATT&CK. The problem I have with MITRE ATT&CK is that vendors started investing into it, right? So they started to say, oh yeah, this is really great. We can use this to actually demonstrate that our products do things. And so you have the evaluation framework, the evaluation system. And yeah, okay, fine. But it doesn't prove that you can actually do what you're doing. It proves that you are essentially capable of reacting against certain threat actors, right? If you think about it, you're acting against, whoops, I'm sorry. Thomas isn't failing today. Let's go back. So you're going to be able to act against specific vendors specific threat actors that you're testing against, right? And yes, every year MITRE kind of pushes that testing framework a little bit further and further up. The problem I have is that I know specifically for some of the organizations that I've worked with today and in the past, the threat actors that are listed here don't really concern me. They're not the ones I'm particularly interested in, right? I might be interested in them in the future, but right now I might have some different visions of which threat actors I want to specifically detect in my environment, which threat actors I know are going to look at attacking my environment or that they want something from me. So yeah, you cover a bunch of TTPs, you can demonstrate it against the MITRE ATT&CK, but is this really what is going to save my organization or protect my organization? So I've been thinking over the past few years, what can be done differently? And so when you're in lockdown, you've got nothing else to do, you basically start to think. Well, I hope you do. Otherwise you're going to get really bored. So I started thinking about things, right? So I started going down the road of how am I going to solve this problem? So I've been in this industry, like I said earlier, a long time. I've done a whole bunch of different roles. I've done AppSec, I've done security architecture, I've done compliance, I've done privacy. I know, I've gone through all the different different places. So I know essentially what different parts of the security lifecycle gets done. One of the things that I've always liked is threat modeling. And, I'm not going to read this. It's the standard OWASP definition. But threat modeling is interesting because you're basically taking your application or your architecture and you're looking at the different aspects of it and you're trying to determine where are the failures in that architecture. You're trying to determine what threats can act on your architecture and try to build in mitigations and look at what controls you need in place. And I've always argued, and I argue continuously with teams. It's like, if you do your threat modeling and you're putting in place controls because you can't really correct whatever weakness you found, those controls should be escalated down so that detection engineering can actually build them up as detections, and so that you can detect if somebody is pushing through those controls that you've put into place. But fundamentally, threat modeling is a risk-based approach. So you decide, okay, I'm going to evaluate my environment. I'm going to build a nice workflow, probably a DFD or a process workflow. And you're going to identify what this application is doing and look at the places where you think there's a risk that it could be attacked. For example, if you have a login page, you're going to evaluate it against brute forcing of that login page or something like that. But does it really work for an incident responder? Does it really work for a detection engineer? If you think about when we're doing incident response, where you're doing detection engineering, you're essentially looking at specific events. You want to detect specific events, but worse than that, you want to detect a timeline of events. You want to find the timeline of events that's going to trigger an alert or that's going to tell you that something's going wrong in your environment. So determining controls and determining mitigations via a process and a risk-based approach gives you a starting point, but it doesn't really tell you that detail enough so that you can build those alerts, so that you can build those response activities. So I started looking for a more practical approach. I was thinking, if I take this idea, how can I actually build something and do something where I'm going to be able to identify if my tool is actually working and if I've got the right things in place to be able to protect the organization. So I came up with 4 distinct things that I kind of needed to understand. And I'm not sure, this is a work in progress, right? So right now, I think it's what I need. I'm not sure if it's exactly what I need, but overall, it's a start. It's a stepping stone, and I'm hoping that it's going to work. And I'm hoping this is going to help you think differently and start to think about how can you think of ways of integrating new tools into your environment that help you detect an organization better. So my first aspect was I wanted a threat-driven approach. Yes, I still want to keep that concept that we have threat actors. They do things. They do things in a very similar way all the time. So I want those threat actors to be detected. But I also like the idea of the techniques and the procedures. So I have those techniques and those procedures. I also want to detect those. But techniques and procedures evolve over time, and they can be mixed together to do different things. So a threat-driven approach for me is more about, let's conceptualize that. Let's not focus on one specific threat actor, but focus on perhaps ransomware and all the different variants of ransomware. Focus on perhaps backdoors and all the different types of backdoors and what could happen. Or focus on lateral movement. Say if I'm very concerned with detecting lateral movement, I'll focus on lateral movement as a threat. Or focus on Active Directory compromise. If you take a look at all the recent attacks that have happened and all the recent big attacks that have been in the news, a lot of them start with the Active Directory got compromised. A Slack user got compromised and their SAML token, which doesn't expire fast enough, was used to access GitHub, whatever, right? So you've got all of these examples that you can rely on, but you want to conceptualize those threats and remove that threat actor so that you can cover a broader base. You want to understand the capabilities as well, right? So what I want to do is I kind of want to say, look, whoops. That's a bit fast. I kind of want to say, what are the? I mean, I've kind of already said it. Sorry, this thing hasn't worked in so long; it doesn't want to work anymore. So I kind of want to understand the capabilities. Are there the TTPs? Yes, from the threat actor's point of view. But what I actually want to focus on here is what are my capabilities? What can I do? What can my organization do? What can my team do? The third point was I need to it to help me define the detections that I can achieve and the detections that I need, right? I don't care that you can detect APT29. I care that I can detect the different capabilities, or that I have the different capabilities to be able to detect the different TTPs and the vast majority of TTPs, and how I build those detections based on the information that I have in front of me. And lastly, I want it to identify how effective my response is. So how do I take those detections that I have, the information that I can gather, and build a response model on top of it? This is really annoying. So the premise that I came up with is, what threats are my organizations concerned with? So I have a specific set of threats. In my current organization, Riot Games, I have a very specific set of threats. You probably saw Project Red got ransomware last year. It's another gaming company. EA was recently in the news as well. So I do know there are threats out there, and there are potentially actors that are going to target me. So I'm going to build kind of like models of the threats that I want to protect myself against. I'm going to identify my assets. That's one important thing that we forget as incident responders is, do we really know our assets? Do we know everything that we really have in our environment that we need to protect? And can we get the right information out of those environments that we need? I'm going to go back to the tools. Have you guys heard of Exonius? How many of you have heard of Exonius? A few of you. So Exonius basically is they're claiming to be a automated, I don't know exactly what they call themselves, but essentially what they try to do is they pull in all of the places where you could potentially have inventory information, like Active Directory, like SCCM, AWS, ServiceNow. And they merge all of that together to basically give you a vision and a view of your assets. And so it'll identify the computers, the users that are on that computer, and things like that. So that's kind of assets, but assets are also your applications. They're also your data stores and things like that. Your network structure, your network environment. If you subscribe to a company like Mandiant that's outside and they give you instant response services or remediation services, first thing they're going to tell you is do you have a network map? It's like, how many of you are in organizations today can swear that they have a proper network map? No one? Of course not. The network changes constantly. And it was been worse over the past couple of years, right? Because we basically completely destroyed the network because everybody's been working from home. You want to determine your detection data points too. I don't care that you can detect a running process. I do, but I don't. What I want to know is, what information do I want from that running process? What information is going to be useful for me to build a detection? And then finally, I'm going to want to determine what response and actions that I want to take and the data points that I need to take those actions. So, for example, if I have ransomware, of course, I'm going to want to stop it from encrypting. So what do I need to kind of understand? What data points do I need to be able to determine if something is being encrypted and how to stop it, or how to essentially maybe capture the way that it's encrypting so that I can potentially reverse it. So the approach that I've been working on right now, and this could change, that's why I put whatever floats your boat on the first bullet point, is I start with a mind map. I like mind maps. If you don't know what a mind map is, I suggest you look it up. I'm not going to go through the concepts of mind maps. There's so many different variations, but essentially it's like you break things down into bite-sized chunks that help you understand what you're looking at or what you're trying to model. In my case, I needed somewhere to start. And for a lot of incident responders and a lot of detection engineering, we're talking about using things like incident response framework, right? So the NIST, right? So I use NIST. And specifically, I use the identify, detect, and respond portions of NIST. I didn't go too deep. I just wanted to be able to kind of label what I was doing into the different phases of where I was going with this. So how do I use the mind map? I primarily use it as a reference graph. I graph a view of the requirements based on the three domains: the identify, specifically asset management, detect, and respond. And then I can quickly kind of like build this structure out to understand where I'm going with my thought process, how I'm going to identify my threat actor, and how I'm going to react to that threat actor and respond and take actions against that threat actor and stop it. So the first phase is basically identify my risk, which I put in the center of my mind map. So that's the start of my process. I've described that risk. Maybe I've described it on a piece of paper locally, or I've described it on a whiteboard, and I've broken it down into the key components of what that risk is. So if it's ransomware, I'm going to have some kind of dropper that happens on the machine. I decide whether I'm going to go further up that chain and say, was it a phishing email or not? But typically what I found is that when I start to do that, I think that phishing email is also a threat in its own right, because it can lead to different types of actions from the actor. So I'll actually extract the threat and put it into the phishing threat and put it into a different mind map. Then I needed a starting point, so that's where I got my identify asset management, my detect and respond bubbles. So basically, what this does is it breaks down the tree into bite-sized components. Okay, so this is going to work. So this would be at the start of my tree for the identify and asset management. So then I'm going to conceptualize this, right? So I'm going to put it up one layer higher. So for asset management, what I'm interested in is, if I still stay on that aspect of a ransomware, I'm interested in the endpoints and I'm interested in the network. I'm potentially also interested in the people. By people, I mean, of course, users. For the detect, I'm interested in the type of tools that I can use to detect. I'm interested in the telemetry that I'm going to gather to be able to create my detections. For respond, I'm going to think first, how am I going to analyze this alert or this detection? What mitigations and remediations can I put into place to help me combat that to help me stop that alert? And what tools do I have at my disposal? And again, by tools, I'm very conceptualizing the type of tool, not the actual product. So I go down one level more. So for network, I need to understand IP assignments. How do I understand which devices are in which network, which subnet, where are they based? For endpoints, I potentially need a CMDB, right? Configuration management database. So I can understand what type of device it is, who it's assigned to, what operating system it's running on, and things like that. So for tools, for tools under detect, you'll notice that I actually put tool 1. I just don't define it right now. Well, I mean, in the practical, this might be endpoint protection. It might be network detection. It might be something very abstract, not a product. For telemetry, I'm going down the same thing. I'm going endpoint. I'm going network. So those are the telemetry points that I'm interested in when I'm trying to detect my ransomware. In the respond, of course, I'm going to have the event data, but I'm going to actually bring in from the detect phase. So there's a correlation between detect and my response. So I understand where I'm going with this. And I also have correlation data. So can I bring in indicators of compromise or other IOCs from reliable sources to be able to fine tune that detection, be able to tell me what it actually is? Of course, then we've got mitigation and remediation, and there I'm talking about actions. So do I kill the process? Do I isolate the endpoint? Things like that. And then the tools would be the tools to be able to do that kind of stuff. Again, very much abstracted. So we keep drilling down. And what happens is you get to an example, which when I'm looking at this example, is basically when I'm talking about detections and telemetry, I have an endpoint, and that's going to deliver different data points. And I'll show you an example in a second of the data points. And same thing for the network. I have data points, and then event data. I might have data points again. For the correlated data, I have intelligence, or I have internal. So maybe I've already had a previous trigger like this, so I can bring in that internal information from a previous trigger to correlate those alerts. Now, notice there's a dotted line here. Basically, what I'm trying to associate here is I'm trying to say, So tool 1 will provide data aspect 1, because I could have multiple tools on an endpoint and they could provide different types of data. There's a reason to the madness, and you'll see in a minute. So this is one that I mapped out for a ransomware type attack. I'd even abstracted a little bit more, and I just said, what happens when I get a malware? So this is really hard to read. It is massive. And it's like, here's the endpoint definition. So what domain is it in? What IP does it have? Does it have an EDR sensor ID? Does it have a MAC? What's the MAC address? Sometimes it has multiple MACs. That's fun. Does it have a location? So do I know if it's in an office, which floor? Does it have an asset tag? Does it have a host? What's the host name? What's the purpose? Is it a build machine? Is it a user machine? Is it a developer machine? What install time? Who's it owned by? What OS does it have? Versions and patches. And we can drill down into that. And you'll notice that there's some lines here. So the IP is actually coming from the network asset information that I have. And in the network, I have a set of ranges. And those ranges might have owners because, they could be, for example, IP ranges in AWS. And I don't know how you guys structure your AWS, but a lot of organizations I've worked with in the past and assign different owners to different organizations in AWS to kind of manage billing, to kind of understand who's running what. Then you have networks and segment names. You might have a topology as well. If it's an office, so it might be hub and spoke and things like that. When we get to the detect, so then I have my telemetry, I have my endpoint, my process information. That's important for me. I have my username. I have my file detection. File detection is a subset of a process info. That's how you've got command line arguments. So this is what I'm basically doing. I'm breaking it down into the minimal basic information, the data points. I'm not breaking it down into something that a vendor tells me that I need, right? I figured if you want to detect these things, you should be able to break down the information that you need. And you see there's a lot of dotted lines. Most of these dotted lines are links to, right? So this context username, the username links back to a user in the asset management. So this gets very complex. The mind map can get very big. I think this is one of my biggest ones, actually. I really drilled down into it to kind of understand what I could detect and how I could detect. I also drilled down into how I could respond. This is the event data that I had. You notice that the event data actually comes from my telemetry. Then I have the process info, so I've got all of this information. I can also pull additional hashes, additional IP addresses by marrying it with other tools. I've got the event data here, so I've got network that's coming from the network. So I've got source ports, I've got destination ports, and I've also got coverage here. So coverage is basically where am I getting my information from, or how can I ensure that I'm getting the right information, and where do I expect to store it, so when I'm responding, I know where to go find it. So once that's done, a mind map really isn't useful to actually do anything practical with it, to build a detection or to look at what kind of tool I want to use in the end. So I built a reference sheet. This was something that I need to automate, and I still need to automate, but that means it's going to require a lot of effort, because I'm basically going to have to take a mind map out of Visio or out of Lucidcharts, and then kind of find all the data points and then bring them into a spreadsheet. Yes, I'm a security engineer and I love to and I started making big spreadsheets. There's no failure in that. And then we complain about finance. Requirements basically the requirements becomes the reference manual, right? So this reference sheet is going to essentially list out all of my requirements based on the mind map. I inventory all the data points that I've put into my mind map, and those kind of become my assignments for threat risk solutions mapping. it helps identify what data points needs a different. It helps me identify the data points at different stages, but it also helps me kind of see, okay, so I have all these data points. Where am I getting them from? Where am I actually getting them from? So what tools do I currently have deployed in my environment? Are they actually giving me that information? And if I can't find a tool that gives me that information, I've basically identified a gap. And that's what was important to me. I wanted to understand where I was failing in terms of detections, what information was missing for me to be able to detect the next best threat actor. It also it's actually provided me with the ability to build a requirements sheet for selecting new products, for selecting new tools, or for defining and building a new solution, right? So if I wanted to actually define a solution that I wanted to build, I can come back to this and look at all the things that I need to put into that solution. And the desired state that I wanted was to have a gap analysis of my capabilities. So how do I do this? Well, like I said, I basically build a spreadsheet. So in that spreadsheet, I break down my mind map. I start to list all the things in the mind map. You'll notice in some places I have a privileges, like here it says privileges 1.-m. So anybody who's done any database architecture knows that basically means you have a relationship of one to many. So one user can have many privileges. So I'm boiling this down and I'm listing this out. So then I have a provided by column. And again, that can be a one-to-many. So these data elements can be provided by the tools that I already have in place. So this tells me the information, where the information comes from or can come from. If I have that tool in place, does it provide that information? Does it come from an application? It also allows me to populate which tools I have or I don't have access to, because there might be tools that I don't have access to but can provide me with this information. And the data can, as I said earlier, the data can come from multiple sources. The use by field tells me, am I using this data point already? Like, I have a playbook. Am I using that data point in my playbook? I have an incident template. I have an incident layout for my ticket. Am I actually using those data points in the incident ticket? I'm doing some forensics work. Am I pulling all the information that I need from that forensic work? Are the tools that I'm using pulling all that information? And again, the data can be in multiple places. I could have a ticket, but I can also have a response tool that needs that data point to be used. So then, name and path is provided. In this example, we see that the process info, trying to get this right. So the process info here, we have name, path, PID, command line arguments. And this is basically telling us that it's provided by EPP, so endpoint protection, EDR. So I did basically, this would be like Carbon Black if you had Carbon Black, Sentinel-1 if you had Sentinel-1 as an EDR. Used by, and you'll see that the process info here, the process name is used by my EPP, but it's also used by my SIEM alert. So the file hashes are used by both as well. Now, you notice under the file hashes, it's blank, and it is supposed to be blank. And my example here is that basically where I'm not using that information that my EDR is providing me. Now, why am I not using it? Couldn't it be useful? Like the command line argument, I'm not using it in my playbook. Let me be precise. The command line arguments could be very useful in my playbook. Think about a PowerShell, or a spawn of a process from a CMD to a PowerShell that has a hash in it. Why am I not pulling that back into my ticket? Because at some point in time, I'm going to need to analyze that hash. So in my playbook, I've already found a gap. I've already found something that's not working for me, right? And this is a more complete version done. So you see I've got this one is the identification part. So to identify all the different assets that I have. this is the process. This is the detect element. So here I'm detecting. So I have all of my provided bys. So in this example, I have Carbon Black providing me information. I have Jamf Protect providing me information. I have Defender. I have Winlog Beat. The idea here is that the reason I have multiple tools is because I have multiple different platforms and I'm getting the information from multiple different environments. But the information is still, from an incident response point of view, from a detection engineering point of view, it's still the same information. And that's another thing, kind of side benefit that I got out of this, is that basically I was able to create metadata elements from all the detections. So if you've ever had to, if you're a Splunk user, you're probably lucky because you can basically throw any logs at it and it basically figures out what fields are in the log. If you're using Elastic, you probably spend a few years trying to figure out the mappings into ECS if there isn't one already. Sorry, Elastic. But that's the hard truth. But I know they're getting better with this. I've been talking to them about it. So it will get better, I'm sure. The problem is I still only want one data point name, right? I don't want to have to deal with multiple data point names. I also blame the other vendors because they basically create they create exports of their logs with varying their own vision of what a data point should be called. So that was the side benefit of that. I just wanted to kind of put that in there, is that I now had a mapping of all the different elements and I could actually identify if I had a name if all of my products were providing me with a process name or a path or a PID or a command line argument. Sorry, I wanted to say something. So if you look at this, in this mapping that we did, basically you'll notice that I'm pretty good on my use by, except most of my fields are only being used by my SIM. That's good. It's generating my alerts. But why am I not using them in my SOAR engine? Why am I not using them in my playbooks? Right? And this was just an example of for this particular threat that we were mapping, we hadn't actually completed the whole process in building the playbooks to use the data. Right. So it also provided me with a way to kind of track the progress of where we were into building our playbook. So this was really cool. So now I'm understanding my organization's capabilities in terms of what things I can detect, what information that I have when I do those detections, what information I have and what capabilities I have when I'm able to respond. It's also allowing me to make better decisions on what tooling and how to use my tooling, what tooling I want to get and how to use my tooling. To give you an example, when we were reevaluating our Mac protection systems, we looked at the different products out there, and we picked in the end Jamf Protect for this particular scenario because it was providing the best possible coverage of information that we needed. And finally, it's actually given me a framework to POC new tools. So when I'm bringing in a new tool, I can now use these capabilities that I've mapped out and look at them and look, hey, cool. Does this tool match this, and that? How much does it match? Can I get the information from another tool? So will it marry properly into my tool set and into my solution, into the solution that I want to build? And that's actually it. So we got time for questions. And I'm sorry if it's a little bit convoluted. I completely misplanned this whole week. Which is Nate. Hey. So the question is, how much time did I spend creating the big mind map that I created? So I didn't create it. The team created it, right? Because there is no one source of information. It's like if you've got a good team, they all have good ideas. They're all able to work. You're going to want to work together. Because at the end of the day, the team is the one that's going to want to kind of, hold on a second. The team is the one that's going to understand those detections that you can make. It's also the one that's going to want to respond. To be more specific, it took us, because we work remotely and plus we work in different time zones, we did 4 2-hour sessions. The harder piece of work was taking the data, taking the mind map and putting it into the spreadsheet. That's why I need to find a way to automate it, because to be honest, it's not going to work. Long term, it's not going to work. Because as soon as you make a change, you have to go back and look in the spreadsheet and change that spreadsheet as well. Hold on a second. I'll give you the mic just to.
Thanks, no pressure. So, I have a question. Hopefully I can get this out right. So when I look at the mind map, it was fantastic in that you can clearly see the process, the decision, the action, the source, the data point.
Yeah.
I looked at that and thought, oh, great. And I can put the application ID here, the control point here, and so on. But I kind of realized, geez, you're getting into an awful lot of work in this. And while it's very useful for me personally to do, I'm not sure I'd take that full document through to my stakeholders, for example. I was kind of curious, once you have it done for the kind of takeaways, what are you bringing out to the other teams to say, right, you wouldn't necessarily show them the map, might not show them the spreadsheet. Is it the gap analysis that comes out that says, look, here's our gaps, this is what we've got, and we have this sitting behind? Is that how it works?
Yeah, you hit it on the nose. So I didn't. This whole presentation is a work in progress because the process is a work in progress, right? But yeah, the goal from the management point of view is to build a gap analysis. The goal from the management point of view is to basically say, hey guys, we're missing this. This is a potential risk for us because we can't cover the variants of ransomware of our concern to us. It's like, we need to rework this. So I need to assign a team to basically do some new detection engineering. It kind of helps me justify the work that we need to do. It also helps me go back, say, to one of the other teams. So like one of the things that I've been working with closely is our privacy team, trying to understand what do we do about privacy and EDR tools.
Yeah.
Right. So there we basically identify all the data points that we want, and privacy is like, no, you can't use that one kind of thing, right? But it's useful. And the thing is, it's like, again, this is, and I forgot to kind of emphasize at the beginning, I don't want to push anything onto you. This is to help you kind of look at things slightly differently and think from the bottom up instead of the product down kind of position, right? Because, I'm going to go, okay, we're out of time, but vendors tend to tell you, oh, we've got this fantastic solution for you. If a vendor tells you that, kick him out of the room, because a vendor cannot build a solution for you. They don't have your problem. You have your problem. You need to fix your problem with your solution. They can sell you a product. They can sell you a tool. That's all. Well, thanks everybody. We're out of time, but I think we've got a break. We can probably take one more question. Sorry? Yeah. I mean, because there was one more question, but I can take it in the other room anyway. But you go ahead if you have it.
Hello. So the question I had is isn't the implementation of the Sigma or the MITRE CARE mapping to attack for the incident responder? Do we really need to build or reinvent a wheel instead of just building on top of the MITRE?
So my intention is not to build on top of the MITRE ATT&CK framework for this. If you want to do that, you're welcome to. I don't have enough alcohol in me anymore today to be able to go off on my rant about MITRE ATT&CK. But the TLDR of the MITRE ATT&CK is, if you looked at it, the early versions, it was very specific. They were mapping techniques, they were mapping TTPs properly. If you look at it now, it takes you like 10 minutes to actually find the TTP. The actual elements of the TTP. They've completely removed the data points. They've completely removed the actual technical aspects of the TTPs. They haven't really, but they've not made it easy for you to get anymore.
Actually, say to answer that, there is actually a JSON version of it available, which actually has all those mapping.
Yeah, but even if you go into the JSON version, a lot of it's missing now.
Okay, might be that.
And no, I don't have enough alcohol.
Yeah. So one more, just one more question.
Go ahead. Go ahead.
Yeah.
I mean, we've got a break, but everybody's welcome to.
Okay. So say, where do we actually draw the line for the money
Slow down.
Yeah. So
Take your time.
Where do we actually draw the line between the money aspect and the ease in the mind map? We actually have to fill the gaps in the mind map when we implement a new technology, but we also have to check if the technology we are buying
becomes a risk-based decision and a money-based decision, and you can't do everything in the world. If you have a good company and they've got a good budget and they realize the benefits of doing this, then that's it. But one of the things I'm playing with in my head is, because I've done this mind mapping and I've done this gap analysis, if you get compromised and you can identify that the compromise was because it was due to one of the gaps that you identified earlier, that just gives you another justification to go back to management and say, I need more money to stop this from happening again. Does that make sense?
Yeah.
Cool. Thanks.